Hey guys, this is Taylor and today we are solving the problem number 3629, which is minimum jumps to reach end via prime teleportation. So this problem is from weekly contest 466. So let's get started. So let's quickly see what is given to us, then we will try run here or we will understand here what is the question about. So you are given an integer array nums of length n, okay. You start at index 0 and your goal is to reach n minus 1 means last of the array, end element of the array. For any index I, you may perform one of the following operations. Adjacent step. Jump to index I plus 1 and I minus 1. So I can go either left, either right, one step. If the index is within bounds. And I can do prime teleportation. What does it mean is, if nums of I, if the current element is prime number, you may instantly jump to any index such that nums of j modulo prime equal to 0 means I can jump from the current element. If current element is prime, I can jump to any number, any element in the array. The only condition is that number should be divisible by that prime number. Okay. So I need to return the minimum number of jumps required to reach index n minus 1. Okay, let's quickly see what is given to us and what is problem all about. Question is, so our question is 23479. Okay, test case is 23479. Okay, so we will start from here. We can start from 0. Now I have to see from this where I can move. I can either move here. Either I can move here if it is valid, or either I can move, I think, here. Because this is prime number and this 4 is divisible by 2. So I have to go optimally. So let's see in test cases how we are going optimally. So first I am moving to index 1. Okay, super. So I will go jump here. Okay, now I am standing here. Now this 9 is divisible by 3, so I can directly jump here. Okay, so let's take one more example. Okay, so here my example is ready. So I will be starting from this 0th index, and from where I can go. So let's discover. I can go here. I think I can go here. I think I can go here. I think I can go here as well. Okay, so the most optimal jump that I should do is basically this one, which is 210, and after this I can go directly here. So if let's say this was not 10, okay, just for example, so I could have moved here, right? Now from this where what all places I can visit? I think I can visit this, and I can visit this as well, but I will not be visiting because this is already visited. Okay, now I think I can visit this one as well. Why? Because 3 is prime. Okay, and this 6 is divisible by 3. 6 is divisible by 3, and I think none of the elements is divisible. So I could have moved here. Now from this I could move here. I could move here, or I think, yeah, these are the only places because 6 is not prime, so I will not be exploring the rest of paths. So I hope the question is clear. So this question is little different, and this question is about graph problem. I was thinking that this is some prefix suffix or some kind of array problem, but not. This is a graph BFS problem. So let's see how we will be solving this. So if you want to solve this, so you have to think in a brute force way, in a way that you have to explore paths. So I will write one more test case here. Okay, so my test case is ready. Now what is the approach to solve this problem? What is the intuition behind solving this problem? So intuition is basically, I will consider each node as a graph. Okay, so whatever element I am having, I will consider this as a graph I, and I can move either I plus 1. That means I can have a directed edge to I, from I to I plus 1, and I can have a directed edge from I to I minus 1 as well. This is given to me. And what rest is given? So I think this can also move here and this can also move here. Okay, now one more thing I am having. So if I is prime, if I is prime, then I can have directed edges to those nodes. Okay, to those nodes which are multiplier of this I. Okay, so if some number, let's say some j, nums of j can divide nums of I, and we get a remainder of 0, so I can have a directed edge at that node as well, at that node as well. There can be multiple nodes. So if I go to create the adjacency list or adjacency matrix for this graph problem, so it will not be optimal, because if you see, for one node we can have multiple paths, and we have adjacent paths as well. We have multiple paths going outside as well for each node. And in the worst case, let's say if we have lot of prime numbers in our array, and we are having total of 10 to the power 5 elements. So in that case, there will be lot of edges, and it will become a little difficult for me to handle space complexity and time complexity, both things. So I need to do something dynamically. Dynamically in means that I have to keep exploring the path as it's coming. So what I will be using is, so I can take help of queue, and with that queue, what I will be doing, I will be just storing the zeroth node, and from that zeroth node, I will keep exploring all the paths. So I know one thing for sure, that there is definitely a path from zeroth node to n minus one node. Why? So if all numbers are prime, let's say in worst case, so I can definitely have some path like this, right? From this node to this to this to this to this, and this to this. Something like this I can definitely have. So this path is definitely I'm having. So considering that as an assumption, I can definitely say that my queue can definitely reach the last node. And in that case, I there is definitely a path, so I can definitely use a queue. I don't need to create and go in this adjacency list or adjacency matrix kind of things. Okay, so let's see the approach what we will be doing. So before telling the exact approach, I will create some variables, okay, some helper variables which will be helping us. So first thing that I will be creating is sieve of prime. So if you don't know what is sieve of prime or sieve of Eratosthenes, so I will put a video link in description. I have created last week only. So if you haven't watched that video, please go and watch that video. It was just, I think, 20 minutes video, but it will help you in lot of problems. So in last week also, Leetcode asked one question which was around the sieve of prime. So if you watch that video, it will definitely help you in many of the future contests, and even in interviews and all. So please make sure to watch that video. Okay. So second thing I will be creating is value to index dictionary or map, whatever you say, hash map or whatever, in different languages. So I will be creating that thing. Okay. The third thing I will be having is, I think, visited node. So visited node, I will be keep track that. So let's say I went here, I went here. Okay. Now from this three, I went here directly. Now let's say this five is visited by this. So do I need to visit from nine? Just for an example, no, I don't need to, because what BFS queue structure is, if I can reach the node, let's say I can reach any node I, or let's say any node K, then that node, okay, if so because I'm using queue, then that means that the distance to reach that key node is minimum. If I'm using queue, if I'm using DFS, then that is another case. But if I'm using queue, then if I am using queue and I'm reaching this node, okay, so whatever distance I am taking, that will be definitely minimum. Okay, so this is the rule of queue. So make sure you keep that in mind. So I will just keep this visited node in my memory so that I can keep track which node I need to visit and which no visit node. So I think yes, pretty much we are done. So okay, so this part I am not going in detail now. I will just briefly mention, but if you haven't watched the video, you can watch it. So this sieve of prime, I will just calculate that all for all the 10 to the power 6. I think the constraints are 10 to the power 6. So I will create an array of 10 to the power 6 size, and this array will basically tell me whether number is prime or not. Okay, in constant time. So it will be definitely order of one operation. I will just go in that index. Let's say I have to go for 10. I have to check for 10. I will check the 10th index of this sieve of prime. If that is true, that means it is prime. If that is false, that means that is not a prime. Okay. So the next thing I will be building is this index value to index dict. So I will be writing Okay, let's try to build for this. Okay, so this is my test case. So what is value to decrement? So basically from keys will be values. Okay, value of array, and values, I mean dictionary values or map values will be index of array. Okay, so let's see. So I will be going this and I will be saying, okay, you are number three. How many indexes in this array contains three? So as far as like this is the first element, so I will be adding just zero. Super. So I went here. Now I will be here. Now I will be going, is six present in this? No, it's not. So let's add it. What is the index currently? One. Okay, super. Now let's see, go to next. 5. What is the index? You are not present. 2. Okay. Next element 9. Are you present? No. So what is the index? I think 3. Okay. Next element 10. Are you present here? No. Let me add you. 4. So 15. Are you present? No. I am not present. Let me add you. Okay. Next element 6. Are you present? Yes, I am present. Yes. So what is the index? I will just add the index here itself. Okay. I will not create a new. So 11. Are you present? No, I am not present. So let me add you. So this will be our value to index map look like. Okay. So in the left side, I'm having the value, the number of the array, and in the right side as a value, I'm having a list. What that list represent? Like in what indexes my that value is present. Okay, that will help us. So for now, don't worry about anything. This is a easy question. This will I will make it very easy for you, but just follow with me. Okay, so we have to create this dictionary. We have this done. Now visitor node, it's very easy. What we'll be doing, we will be just doing one thing. So I can create something like visited, and I can create a list, I can create a set, whatever. So for now, I'm creating a set. Okay, I will be creating a set, and as soon as my node is visited, I will be pushing that into the set. Super. Now, let's talk about the idea. Let's talk about the intuition. How we will be solving this problem. Okay, so let me write down this same thing 3, 6, 5, 9, 10, 15, 6, 11. Super. Okay, so what I will be doing, I will be starting from zeroth node. Okay, I will be starting from here. Now, I will be asking what all places I can visit. So I can visit this, but this is invalid. So I will ignore this. I can visit this. Yes, I can visit. But one more thing I will be doing. So I will be creating one distance array. Okay. So my distance array will look like, how many places? The 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6. I think 5, 6, 7. Super. So so all distances will be infinite except the zero. This is the graph traversal looks like. I will be starting from three. So I will be doing two things. No, I will be doing three things. Okay. First thing that I will be doing is, can I visit left node? If yes, I will visit. Can I visit right node? If yes, I will visit. Third thing is very important. What I will be doing, I will be checking if this is a prime, I will be visiting all of his multipliers. Okay, so I think 6 is multiplier, 9 is multiplier, 15 is multiplier, and 6 is multiplier again. Okay, so I will be visiting this nodes, and I will be putting distance of 1 in these places. Okay, let's do it. So it's very easy problem, guys. So I'm here. Now I can visit this, so I can mark this distance as 1. This is invalid, I will not be doing anything. I think it's a 0, 1, 2, 3, 4, 5, 6, 7. So I am here. Now I can visit this node and I can mark it as 1 by 1 because the cost of reaching 3 is 0. So I can reach in constant time in like in with one weight I can reach here. I can reach here. I can reach here and I can reach here as well with one weight. Okay, super. So I think 15 this 5 I will write update it super. So I will be maintaining queue and I will be putting these things in queue. So I popped the 0 and I saw that I can visit index 1. Let's talk about 6. So for now, I am talking in terms of indexes. Sorry, in terms of values. For just to make the question little easy to understand, I'll be talking in terms of values. But while we are coding, we will be maintaining things in terms of indexes. Okay. So for now, I have added 3 here. Now I popped 3. Initially, I was talking about initial. So from 3 node, I can visit, I think 6. I think I can visit this 9 as well. I think I can visit this 15 as well. And I think there is one more 6. Okay. So I let me put all these nodes in the queue. So 6, 9, 15, and 6. Why we are putting 2 6 here? Because we are dealing with indexes in practice. So here actually it was 1 and it was 6. Okay, I hope you got it. Okay, super. So this task is done. Okay, I have done 3 things. What I have done, I tried to explore the left part, which was invalid, so I didn't do anything. Now I explored the right part, and I explored all the paths because this was prime number. Okay, now uh, let's move forward. Now I'll be. This is my queue. For last first in first out. Okay, yes, first in first out. So 6 will be popped out. Okay, from 6 where I can go? I think I can go here, but will I go? Its distance is already 0. It's not infinite, so it means it's already visited. So okay, I need to add in visited also. Okay, so visited may I will add. Okay, I have visited 3 node. Okay. Oh, super. So I will say that its distance is 0. That means it's already visited. So do I need to do anything? No, I don't need to. So okay, I will try to go in the right side. Can I go right side? Yes, I can go. So I can go 5, and it's not visited. So let me update its distance so that if any other node try to visit this node, it won't be able to visit. So what will be the distance for it? What do you guys think? So distance to reach 6 is 1. So can I add one more here and I reach the 5? Yes, I can. Okay. So let me put a 2 here. Super. Now is left side is done, right side is done. Now 6 is a prime or not? It's not prime. So I don't need to do anything. My task is easy. Okay. Nice. So 6 is also done. Super. I will pop out 9. Okay, okay, bro, 9. Where all places you can go? Can you go left? Yes, you can go, but is 5 visited? Is 5 visited? Yes, it is visited. Distance to reach is 2. I won't be doing anything. Okay, I will be trying here. Are you visited? Oh, I'm not visited. Okay, let me visit you. Let me update your distance as well. So what is the distance to reach this 9? Okay, let me tell. Let me see. 0, 1, 2, 3. So distance to reach 3 is 1. So can I update 2 here? Yes, I can. Okay. Now left part done, right part done. Do I need to do any other exploration? 9 is not prime, so I don't need to. Okay. Let me remove this. Okay. I think we are going good. Yes. Super. I think yes, 10 I need to add here. Okay. Now I will pop the next element 15. So 15, let me ask 15, what are places you can go? 15 is telling me I can go left, I can go right. But left is visited, right is also visited. How? So 15th is 5 index and 4 is visited, 6 is visited. And 50 is not a prime number, so you can't visit anything, okay? Your work is already done by someone else. So let me remove it. Okay, it's turns 6 turn now. Okay, now 6. 6 is telling, can I go left? No, it's already visited. It's having distance of 1. Can I go right? Yes, I can go. Okay, let me go it. So I will go to the 7 now. If I'm going 7, what is the distance it's taking? I think I'm reaching in distance of 2. Okay, fine. Let me update. Okay, super. Now let me add 7 here as well. Sorry, I think 11. Let me add 11 here as well. Okay. Now, can I go somewhere else? Can I go somewhere? Are you prime? First of all, I need to ask, are you prime? Okay. So it's telling me, no, no, I am not prime. So I will not do anything and I will skip this part. Now, one more thing. This way we are able to basically got our answer, and 2 is our minimum distance. So the minimum cost that would be like this and this. Okay. So this will be our part. that we just dry run. Okay, when we write code now, you will get proper clarity what we are doing. Now one more thing that I want to mention is whenever we checking that let's say we popped any element. Okay, we popped any element, we explore the left part, we explore the right part. Now when we check na, okay, it's prime or not. In case if it's prime, okay, then one more thing we have to check, is this visited? Okay, if that is visited now, I will not be visiting that again, because so what I am doing here, see, I will be using this. Okay, in code we will be using this. In that code, it's telling me that from 6. Okay, let's take example of 6, because 6 has in multiple indexes. If I have explored 6, okay, if I was at 3, okay, I was at 3. Now it visited all of the 6, right? It didn't left any 6. It visited all of the 6. So I will put a 6 here in my visited node. Here I will not be putting index. I will be putting the value itself. And if this 6 is visited by any of this number, so I need to visit? No, I will not be doing the repetition of task. Otherwise, I will definitely get a TLE. Okay, this question is having 10 to power 5 constraint, and our I think code complexity would be something around this square root of n plus I think log of n. I think somewhere around this our complexity will look like. So I don't have to do any other extra stuff. Otherwise, I could get the TLE. Okay, so that way I hope it is clear. Now let's try to write pseudocode. I think that will definitely help you understand properly what we are doing. Okay, so I will be writing little clean pseudocode this time, and we will be commenting also, so that you can understand. So first thing, let me summarize first of all what we have to do, what all things. So first of all, calculate C of prime. Okay, why we are calculating this C of prime? To get whe- whether number is prime or not in order of one time. Okay, second thing what I need to do, I need to create some helper variable. Okay, so what are the helper variables? First of all, this c of prime is also a helper variable. Second thing is visited array. Third thing is this value to index array. Okay, and what is this value to index array? So the keys will be values of array. The values will be how many indexes. So for example, this 6. So I will be storing 1 because first index, and it's present at the 6th index. Okay, so I will be storing like this. Now what next I need to do? Um, I think I need to create a queue as well. Let me write here. So val to index. Second is visited. Third is queue. Fourth is distance array. Okay. Do I need to do anything else? I think no. Okay. Let's try to write pseudocode. So I will not be writing pseudocode for this calculate C of prime. We'll be directly using the code. So let me start this thing. To create value to index array. I think we guys can do it very easily. I'll be creating a dictionary or hash map, whatever. So I will put the C++, Java and JavaScript code in description. You can follow me along that. Otherwise, this is algorithm, so don't worry about it. So this is kind of hash map thing. Okay. Now what I need to do? I need to create a basically value to indexes. So I will be iterating for index in from, let's write from 0 to n minus 1. Okay, and what I need to do, I need to put in value to index. So value to index will be whatever index I am having, sorry, whatever value I am having. Okay, so I will be getting a list, a list like this, and if there is no elements, so I will be getting an empty list. So in that case, what I need to do, I need to append. What I need to append? The index, this index. Okay, super. So our this task is done. Now I need to declare the visited array of size. How much size? So okay, this is our set. So I will be creating an empty set. Okay, empty set. Super. Now third thing is distances. So distances array will be looking like first element zeroth node is zero, otherwise all are empty, infinite. Okay, all will be infinite, and this will be having a size of n. How much my array length will be. The third thing I need to do is queue. Okay, and I will be putting zero in my queue. Okay, so zero will be there. Super. Now let's try to run the code. Write the pseudocode. So how I'll be starting? So I think we are pretty good. We have calculated this part. Okay, let's start. So I will be starting my traversal in the DFS. I mean in BFS. So I will be writing something like while queue is not empty. Okay, let's write little clean. Okay, super. So while queue is not empty, I will node equal to queue dot pop. I'll pop some element from the queue. Okay, what I'll be doing next? So I need to visit left part. Visit left. If not visited, okay. So let me do it. So I will be okay. If not visited, this is a pseudocode. Okay, and node. So this is my index. Okay, please remember this is my index. If node minus one is valid index, then what I need to do? What I need to do? I need to visit it, right? So how I will be visiting it? First of all, I will put it in queue. Okay. So next time, please go and traverse this. Second thing, what I will be doing is, so distance of this node, I think node minus one. Okay. It should be node minus one. Distance of this node minus one, can I update with something like this? So whatever cost I am, whatever distance is required to reach the node, can I add plus one here and I can visit this node? Yes, I can. Okay. So second thing, what I will be doing, let's change the color, I think. Okay, let's keep it same for this. So visit right node, right, if not visited. Okay, it's if. Now, if not visited of n node plus one, right wala, and node plus one is valid index. I need to check for valid index. Okay. So if it is a valid index and it's not visited, then what I need to do? I need to put in queue, please visit it. Okay. So distance will be node plus one equal to one plus distance of node. So the same funda. Okay. So if I'm requiring some distance to reach node, can I add one plus and I can reach this one? Yes, definitely I can. Now, second thing. uh, left part is done, part is done. What is remaining? So I need to do one thing. If number is prime, okay, so let's write here itself. Let me write. So if number, I mean the node, so let me write something like this. Nums of node is prime, and what is the case? It's not visited. Okay, this is very important condition. Otherwise, you will keep iterating like little longer. Okay, that will not be good for time. So if not visited, then what I need to do? I need to check what all numbers are the multipliers of that number. In that, what will help us? This hash map will help us. Okay. So what I will be doing here is where it went. Okay, I think here. So now let's see what I will be doing. So let me copy paste this thing. We'll discuss there. 3, 6, 5, 9, 10, 15, 16, 11. Okay. So let's see what we need to do. Let me add indexes as well. 0, 1, 2, 3, 4, 5, 6, 7. Super. Now, what we need to do? So, I need to find the multipliers of this 3, right? So, I will be starting from 3 into 1 and I will be checking. I will be asking this. Do you have three? Do you have three? Yes, it will be telling yes, I am having three. What is the index? It will tell me zero. So I will check. I will go and check. Hey zero. Are you infinite? It's telling me no, I am not infinite. So do I need to visit that node? No, I don't. I will not be putting in my queue because it's already visited. Its distance is already reached, so I don't need to do anything. Okay, super. So, I next time I will be going. So 3 into 1 is 3. I got. So I didn't get anything. Now I'll be writing 3 into 2. I got 6. I will be telling that 6. Are you on dictionary? Are you on dictionary? It's telling me yes, I am. Yes, I am. At what all places you are? So it will tell me I am at the first index. I am at the sixth index. Okay. What you have? What you have? So I will be asking, okay, distance of first. Are you visited? Distance of first. Are you visited? It will tell yes, I am visited. And I'm asking distance of six. Are you visited? Let's say for example, so distance of say it's telling I'm not visited. So what I'll be doing? I will be putting that in queue. Okay. Oh shit. Okay. So I will be putting that in queue. Queue dot put this six. Okay. Index of this six and distance. Let's visit that as well. So distance for this six index. Okay. I'm talking about index. Distance of six index equal to 1 plus whatever distance is required to reach 3. I hope you got it. Okay. So this same part we'll be doing here. If you have any doubt in this part, let me know. Okay. So it's very easy part only. So I'll be doing something like this. So if it's prime and if it is not visited, then only I have to do. What I need to do? I need to basically start from for I equal to 1. Let's write a while loop. I think that will be little better. So while true, I will be writing an infinite loop here. Okay. It will definitely end, but let's start. So I equal to 1. Now what I need to do? New node. Okay. So new node will be whatever nums of node I'm having into I. Okay, so that way I will be able to basically I'm trying to find the multiplier. Okay, so if I'm at 3, I will try to multiply and see where I can go. I will try to multiply it with 2 and see where I can go. Okay, what is the next thing I need to do? I need to check whether this new node is present in that map or not, that dictionary or not. For that, let me first calculate the index of it. New node index equal to uh, okay, so let me write for loop itself here. Okay, so for new node index, because that hash map, if you remember that hash map gives me index directly, so I don't need to worry about anything where it went. I think this part. So this will give me directly the indexes, right? So let's start. So for new node indexes in this value to index dictionary, I will pass new node. You tell me the indexes of it. Now it will give me some indexes, and now what I need to do. If distance is infinite, then only I need to do what I need to do. Q dot put simple, q dot put new node. Second thing what I need to do. I need to visit that node and I need to update the distance. So new node index, it should be the index only. Okay, so new node index equal to 1 plus whatever distance I'm taking to reach node, my node. Okay, because I was traversing from the node. Okay, if you got lost, let me tell you again. So we were here, we were here. Okay, wait, sorry, we were here, we went here. Now what we were doing, we were exploring all the multipliers, this multiplier, right? So what will be distance of 9? 1 plus whatever distance of 3. What is the distance of this 15? 1 plus distance of 3, right? That's what we are doing here. Super. So if that is done, what I need to do, there is very important step. If you miss that, you will break the code. So after this while loop is done, I need to visit my node. So visited dot add my node, current node. Okay, whatever is being processed in the queue, I will only add that node in the queue. That is important step. Now in the last, after completing all the nodes, so if let's say all the nodes are visited and everything is done, I'm outside this loop, while queue wala loop. So in the last, what I need to do, I need to just return the distance of my n minus 1th node. Okay, I think this part is done. And one more optimization I think I can do. So as soon as my n minus 1 node is reached, if distance of n minus 1 node is not infinite, then I think I can break. So what does that mean is, if I'm able to reach the n minus 1 node, now I don't need to do any traversal and all. So because I'm only worried about to reaching the n minus 1 node. So as soon as that is done, I will be going out of the loop. I hope you guys got it. If you have any doubts, please feel free to comment down. So we'll be quickly writing the code for it. I think video got little lengthier. So I will be writing code for sieve of prime here. Okay, sieve of erostonosis, whatever it is, sieve of erostonosis, this part. Okay, so I will define some max range here, which is 10 to the power 6, and I will be adding +1 here. I will not be going in very detail for this code. Please pause the video if you haven't watched yet. So prime of I will be considering all element as prime for this max range, and I'll consider that 0 and prime of 1 are not prime numbers. Now I need to start from 2. I need to go till square root of max range +1. No, I think square root. Okay, +1. That's right, +1 here. No issue with that. Okay. Now, what is the next thing I need to do? If prime of I equal to true, what I need to do? I need to start another loop for j in range I into I. Why we are doing I into I? Why we are doing all these things? That was in very detail, in very depth we discussed there. Why we are having the jumping of I here. Everything is discussed in very detail in that video. So I can tell that this prime is false. Super. So I'm just writing this code out of this solution, out of this class, because this code will be every time same. Okay. So I will not be doing again and again computation of this 10 to power 5, 10 to power 6 iterations. I will be doing it only one time, and I will be using it throughout the code. Like let's say if there are 100 test cases, this code will be running only one time, and it will be getting reused all the 100 times. Okay. Super. Now this the first part is done. We are here. Okay, so first part is done. Now I need to calculate this. So value to index, it's a dictionary. Okay, I need to calculate this, so I'm using something like this. Okay, let's write this. For I in range n, I will be defining n equal to length of nums. What I need to define value to index. Let me write a default predict here. So default list is nothing but a dictionary only. Okay, so value to index, I will be using nums of I dot append the I. Okay, so we are doing whatever we have discussed here. Whatever we have discussed here, we are doing the same thing. Super. Now the second thing, visited array. Visited of set. Super. Now the distance. Let me write a shorter version. The float of infinite. So everything is infinite. Nature has been infinite. Now distance of 0 will be definitely 0. Okay. Super. So what is the next thing that I need to do? I need to start the queue, I think, right? Okay. So q equal to take q and q dot append 0. Super. Now let's start the iterations and see. So while q, I will be writing while q. That will be enough in Python. Now I need to pop the element q dot pop left. So we are popping from the top of the queue. Okay. First in. Super. So what is the next thing I need to do? Visit the left node. What is the next thing I need to do? Visit the right node. What is the next thing I need to do? Visit the multipliers. If it's prime and it's not in visited array or visited set. Okay, so I have written the comment so that you got the idea. So we just need to define these things and we are pretty done. So you can see that this is a very easy solution, very easy explanation. If you like the video, please make sure you subscribe the channel and give a thumbs up. That will really motivates me. Okay, so I need to check. So visit the left node if left node is left node exists. Okay, if node -1, okay, I'm going left side, is greater than equal to 0. Okay, greater than equal to 0 means it should be greater than equal to 0. My index start from 0 and distance of node -1. Okay, I'm checking distance of node -1 is equal to float of infinite. That means it's infinite. Okay, if it's infinite and it exists, then only I will be what I need to do, q dot append node -1 and distance of node -1. Let me visit it. What I can write, can I write something like the distance of node? What does that mean? So whatever operations, whatever distance I am requiring to reach 3, so +1 if I will do, so I can reach 6, right? That's what. Okay, now the next thing, visit the right node. See how simple it is. So if node +1, now how will we checking? If it should be less than n. It's simple. Distance of node +1 is equal to float of infinite. Okay. Now q dot append node +1 and distance of node +1 would be definitely equal to 1 plus distance of node. I am not explaining this again. Okay. So I hope you guys got it why we are doing all these things. Okay, super. Our code should be very clean every time, even in interviews and all. It really makes an impact to the interviewer. Okay, so next thing, if nums of node, if prime of nums of nodes, I am checking if this is a prime, okay, is equal to false, equal to false, and or it should be or nums of node in visited. So I can continue. What I'm doing here is basically if either it's not prime or either it's already visited, then I don't need to do anything. Super. So what is the next thing that I need to do? Means it is a prime and it is not visited. Let's visit it. What an issue. I will be starting from 1 while true if now one more thing, one more important thing. I'll be writing something like this here. Max equal to 0 and max equal to max of maxi comma nums of I. So what I'm doing here is basically I'm just keeping track of what is the maximum value of my array, and this I will be using here. Why I'll be using here? So when I'm multiplying, where is our array? Okay. So when I'm multiplying, okay. So 3 into 1, 3, 3 into 2, 6, 3 into 3, 9, 3 into 4, 12, 3 into 5, it's 15, and 3 into 6, it's 18. Do I have 18 here? Do I have any element greater than 18? No, I don't have. The maximum element that I am having is 15. Okay, so if as soon as I reach this state, I will break. Okay, this 18 you reach because every element is less than this 15, so I will not be going beyond. Okay, so where I was? Okay, so node, uh, okay, I equal to 1. Okay, so if nums of node, okay, I will be checking what is the value there into y is greater than maxi, then I can definitely break out of it, right? Otherwise, what I can do? I can create the index. First, I will find out the index. Okay, So let me write new node here first. New node. What we are doing here, nums of node into I. Okay, and let me write new node here. That will be like little cleaner code. Okay, so now what I need to do, I need to visit all the indices of the new node. So if I'm able to reach at the 6, if I'm able to, okay, or pseudocode dots a little longer. If I'm able to reach this 6, then I need to figure out how many sixes 6 I am having. I'm having this 6, I'm having this 6 as well. So from this 3, I can in a single time I can visit this and I can visit this. That's what I'm doing here. So I will ask for new node index in. What I'll be using my this dictionary value to index. Oh, node. I think new node. Okay. And what is the next thing I need to do? I need to check whether it's visited or not. Okay. So if distance of new node index equal to float of infinite. If this is not visited, then only I need to append new node index and distance of this new node index can be calculated by the resistance of node. Superb. Okay. In the very last, we need to add the node in our set there, so what we are doing basically here is, so as soon as my basically iteration is done, my node is visited, I'm adding it in the last, that okay, my node is visited. Now the next time if you're able to reach this node, don't add it in queue. Okay, super. So in the last, okay, one more optimization I was having, right? If distance of n minus 1 not equal to float of infinite at any point if I am able to reach n minus 1 distance, then I can break the loop, because that's what I'm interested in, right? Okay, in the last I can return definitely a distance of n minus 1. So basically I think we are pretty done. And why I'm not writing any minus 1 condition here, because one path I'm very sure, okay, if all of these elements are prime, so the one path every time exists. This path definitely exists. Okay, so let's try to quickly check it. If we have made any mistake, max equal to 0. Okay, nums of I distance becomes 0. Oh, sorry. It should be first declared, then it should be assigned. Okay, q deq. I had appended 0 there. Super. I am creating node. If it's valid, then I am visiting the distance. Okay. Okay, node plus one looks good. It should be less than n. Okay, and prime nouns of node equal to false. That means it's not a prime number or it's visited. Then I will don't do anything. Just I will start. Okay, I forget to add I plus equal to 1. See how many mistakes, silly mistakes we are able to find out in the quick check. Super. So new node is equal to nums of node into I. Okay, so whatever node index I'm having, I will be extracting number and I will be multiplying it. New node. New node is greater than max. I can definitely break it. Otherwise, I will be exploring what all indexes it's having. So if it is not visited, I will be adding in queue and I will be updating my distance array. Simple. And I plus 1 is basically for this and visited and this. Okay, let's try to run and see whether it's working fine or not. It was little complex, but let's see. Okay, I'm getting some error in which part? In this part. Okay, it's telling me that it's not callable prime. Oh, sorry. It should be like this. It's a array. That's why. Okay, we are getting a correct answer. Let's try to submit and see whether it's working fine or not. Okay, we are getting a wrong answer. Maybe we did some mistake, definitely. Okay, so I have figured out what is the error here is. So I want you guys also to figure out. So I have written, you guys were following me while I was writing code, while I was writing this pseudo code as well, right? So I had mentioned a lot of things here, and we have written the same exact code here. So can you guys guess what can be the error? If you can guess, please let me know in the comment section. If you are able to guess at this point, pause it and go through this code and pause the video and check what mistake we are doing. So if you have guessed it, then please let me know so that I can know that okay, you are able to understand. And if not, don't worry about it. So what we were doing, so we were adding nodes here, okay? But what we should add, ideally, it should be it should be value, okay? So node is basically index, but what we need to add, we need to add the exact value. Why? Because when we accessing this here, when we accessing his here, we are accessing via value, okay? And we should not add index, we should add value only. Why? Because we discussed now. So we have this 6 here and this 6 here. If we added just the one, then we should be again calculating for the 6, but this 3 is able to reach 6 and 6, both 6s, right? So I need to add this 6. Okay, this 6 is visited, so if any time in future you got 6, don't need to visit because it is visited by 3. Okay, that's why. I hope you got it. So that silly mistake, subtle mistake that we did. And nums of node, let's try to see whether it is working fine or not now. Okay, it's working fine. Let's try to submit it. See, 921 test cases were passing with that mistake. I don't know why. Okay, but okay, this question is accepted now, and I hope you are able to understand what you are doing. The video became a little longer, but we discussed in very detail each and everything. So if you like the video, please make sure you subscribe the channel. That really motivates me, and give a thumbs up. And thank you very much for watching the video. Thank you guys.